The sun generates more energy in one day than the world needs in a whole year. To be able to capture this clean energy, we use solar modules made from silicon. After oxygen, silicon is the second most abundant element in the Earth's crust. Silicon is typically found in sand and rocks. REC turns sand into silicon, wafers, cells and modules, and is proud to own the complete value chain from sand to solar energy. The first step in making a solar module is to purify silicon. This is done by making silane gas from metallurgical silicon, and then growing new silicon crystals from the silane gas. REC produces silicon using both the Siemens reactor and the modern fluidized bed reactor processes. With the industry-unique fluidized bed reactor, REC has successfully cut production time and costs. The fluidized bed reactor also reduces energy consumption by 80 to 90% compared to the Siemens reactor. This is helping REC to maintain an industry-leading energy payback time of 1 year. Silicon is made into wafers in our wafer factory, where it is melted in large furnaces. Each furnace run crystallizes a market-leading amount in excess of 1 ton of silicon. After 42 hours at temperatures of up to 1450 degrees centigrade, the silicon ingot is ready. The ingot is cut into blocks by high-precision saws. In preparation for cutting the blocks into wafers, they are polished and glued to a guide. Each block is cut into more than 600 wafers using a super thin wire. After being cut, the wafers are cleaned and separated. To make a solar module, the wafer first needs to be made into a solar cell. In the cell production line, the wafers are cleaned and etched. The etching process creates an uneven structure on the cell, cutting reflection and allowing for a better capture of sunlight. Thin fingers are printed onto the cell to capture the electrical current being produced. The fingers need to be the correct thickness to achieve the highest solar efficiency, which determines how much electrical energy a cell will produce. The final stage of cell production is to test and sort the cells according to efficiency. A module consists of several layers: the backsheet, a first layer of EVA, cells, a second layer of EVA, and glass. The module production process starts with positioning the glass face down on the manufacturing line. The glass undergoes treatment to optimize light transmission. The EVA is put on top of the glass and functions as an encapsulant for the module. The cells are stringed together and soldered. The automated production process ensures a high-quality end product is consistently achieved. The strings are placed on the EVA layer and soldered together. An additional layer of EVA is placed on top of the cell strings, followed by the backsheet. The module is now ready to be heat sealed in the laminator. This process takes about 15 minutes. After lamination, the module is trimmed and prepared for framing. The frame is used to strengthen the module and allows the module to withstand loads of up to 5,400 Pascal. A junction box is added to the back side, and the module is then tested to verify its power output. The modules are packed in a protective wrapping and are now ready to be shipped and installed. Our modules are used in all types of application, ranging from smaller home installations to large power plants. REC modules give an industry-leading high performance ratio as demonstrated by the latest photon yield measurement tests. The modules come with a 25-year warranty, are easy to recycle, and are optimised to produce energy in all sunlight conditions.